Okay, so this is Unit 2 in Geometry. The unit is called Logic and Proof. This is Lesson 1. Lesson 1 is called Conditionals, Converses, Biconditionals, Truth Values, and Counterexamples. So this lesson has a lot of writing in it. Okay? So one definition to start, it's called a conditional or a conditional statement. A conditional is another name for an if-then statement. So for example, if you are not completely satisfied, then your money will be refunded. Conditionals have two parts, okay? The part following if is called the hypothesis. And the part following then is called the conclusion. Okay, so example 1, identify the hypothesis and the conclusion. If two lines are parallel, then they never intersect. So for the hypothesis, you don't put the word if. So I'm going to say the hypothesis is two lines are parallel. In the conclusion, I'm not going to write the word then. I'm just going to write they never intersect. Okay, example 2, write each sentence as a conditional. So you have to write it in if-then form. Just make sure your sentence sounds good grammatically. So 2A, a rectangle has 4 right angles. Write that as a conditional. I'm going to say if a figure is a rectangle, then it has 4 right angles. Okay, example 2B, an obtuse triangle has exactly one obtuse angle. I'm going to say if a triangle is obtuse, then it has exactly one obtuse angle. Okay. Every conditional has what's called a truth value of true or false. So every conditional statement, it's either true or false. That's called the truth value. To show a conditional is true, you must show that every time the hypothesis is true, the conclusion is also true. It must be true every single time. To show a conditional is false, you only have to find one. It's called a counterexample. You only need to find one counterexample. A counterexample is something that makes the hypothesis true, but the conclusion false. Okay? So example 3. Show that the following statement is false by finding a counterexample. Okay? If it is February, then there are only 28 days in the month. A counterexample would be that February has 29 days in a leap year, which was 2020. Counterexample, February has 29 days in a leap year. So that's my counterexample. It makes the hypothesis true, but the conclusion false. Okay, this next definition is called a converse. The converse of a conditional statement switches the hypothesis and the conclusion. It's called a converse. Okay, so example 4, write the converse of the following. If two lines intersect to form right angles, then they are perpendicular. The converse, you're going to switch the hypothesis and the conclusion. So it will be, if two lines are perpendicular, then they intersect to form right angles. Again, just make sure your sentences sound good grammatically. Okay, so next I'm going to pose this question. Is it possible for a conditional and its converse to have different truth values? Can one be true and the other be false? And the answer is yes, it is possible. So example 5, which conditional has a false converse? So 5a, if two planes are parallel, then they have no points in common. That's true. The converse, if two planes have no points in common, then they are parallel. That's also true. 5b says if a point has an x-coordinate of 0, then it lies on the y-axis. That's true. The converse would be if a point lies on the y-axis, then it has an x-coordinate of 0. So if you remember back to algebra, that's true as well. Let's skip C and let's do D. If two angles are congruent, then they have the same measure. That's true. The converse, if two angles have the same measure, then they are congruent. That's also true. So that leaves choice C. If a figure is a square, then it has 4 sides. That's true. But the converse, if a figure has 4 sides, then it is a square. That's not true. Okay, so let's explore why. Okay. So the answer is choice C. Choice C has a false converse. I'm just going to write it out. The converse, if a figure has 4 sides, then it is a square. Okay. The reason why that's false is because I can give you a counterexample. A counterexample would be a rectangle. Or you can say a parallelogram or a rhombus or a trapezoid or a kite. Because I went with rectangle because a rectangle has 4 sides, but it's not a square. Okay, so that's a counterexample. That's why choice C has a false converse. Okay, so halfway done, 2 more pages. A couple definitions now. When a conditional and its converse are both true, you can combine them into one statement. That's called a biconditional. Bi means 2, so biconditional means 2 conditionals. Okay? You can combine this by combining the 2 sentences with the word and. That's a little messy. You can write this more concisely by using the phrase if and only if. And abbreviated more, that's you can abbreviate that IFF. Okay, so example 6. Write the converse of the given conditional statement. If the conditional and converse are both true, then you're going to write a biconditional. Okay? So here's my conditional. If 2 angles have the same measure, then the angles are congruent. Okay, it says write the converse. So the converse would be if 2 angles are congruent, then they have the same measure. If 2 angles are congruent, then they have the same measure. Now the next question is, are both of those statements true? Okay? And the conditional is true, and the converse is true. So I'm just going to note that both the conditional and converse are true. So since they're both true, you can write a biconditional. Again, but they have to both be true, or else you cannot write a biconditional. The biconditional would sound like this. 2 angles have the same measure. If and only if, that's the key phrase, if and only if they are congruent. Okay. Now we're going to do the opposite for example 7. Okay. You have 9 examples today. So example 7, you're given a biconditional, and you have to write 2 statements that form it. Okay, so here's the biconditional. A number is divisible by 3 if and only if the sum of its digits is divisible by 3. So you got to write 2 statements from that. So here's my first one. If a number is divisible by 3, then the sum of its digits is divisible by 3. Okay? Then the sum of its digits is divisible by 3. Now let's go the other way. For my second statement, I'm going to say, if the sum of a number's digits is divisible by 3, if the sum of a number's digits is divisible by 3, then the number is divisible by 3. Okay? All right, one more page. 2 more definitions. In logic, a conjunction is a compound sentence formed by combining 2 sentences using the word and. Okay, it's called a conjunction. And let's just note this. A conjunction is true only when both parts are true. They have to both be true. If I say this and that, it's only true if both parts are true. Now we're going to do one more definition in logic. A disjunction is a compound sentence formed by combining 2 sentences using the word or. Okay? So a disjunction is true as long as at least one part is true. So I'm going to say a disjunction is true when either or both parts are true. Okay? Either or both. As long as at least one is true, it's true. Either or both parts are true. Okay, so 2 more examples. Example 8 is about conjunctions. State whether the following conjunctions are true or false. Okay, part A, blue is a color. That's true. Okay, and 7 plus 3 equals 10. That's true. Both parts are true, so it means the conjunction is true. Part B, 1 minute is exactly 60 seconds. That's true. And 1 hour is exactly 55 minutes. That is not true. So the first part was true, the second part was false. So it means the conjunction is false. They have to both be true for it to be true. In part B, 3 plus 4 equals 6, no. And all dogs are brown, no. They're both false, so the answer is false. They have to both be true for it to be true. Okay, last example. Example 9, the same sentences, but now we're doing disjunctions. Okay, so part A, blue is a color, that's true. 7 plus 3 equals 10, that's true. They're both true, so the disjunction is true. You only need one part to be true for the disjunction to be true. Because it's or. So part B, 1 minute is exactly 60 seconds, that's true. Or 1 hour is exactly 55 minutes. So that part is not true, but the entire sentence is actually true because it says this or that. So you only need one to be true. The first part is true, the second part is false. But as long as one part is true, then the disjunction is true. In part C, 3 plus 4 equals 6, that's false. Or all dogs are brown, that's also false. Both parts are false, so it means the disjunction is false because neither part was true. So there was a lot of writing in that lesson, but you are going to need to know a lot of that stuff for the rest of the unit. Okay, so again, that was Unit 2, Lesson 1. There's a lot of topics. The lesson, again, was called Conditionals, Converses, Biconditionals, Truth Values, and Counterexamples.